Okay, so today we are going to discuss the current carrying coil in a magnetic field. Okay, so let's see here we have uh, a current carrying coil in a magnetic field. Okay, as you can see in the diagram here, we have a permanent magnet with north pole on the left and south pole on the right. Okay, and in between of the permanent magnet, we have a current carrying conductor in a coil. Okay, and as you can see, the direction of the current is as shown. Okay, so uh, the next slide, okay, we can see draw magnetic field line for the permanent magnet. So magnetic field line is always from the north to the south. Okay. Okay. And then number 2, draw the magnetic field lines for the current carrying coil. Okay, so to determine the direction of the magnetic field lines, we use our right hand grip. So for the first one, the cross sign, okay, current into the paper. So we take our right hand and take our thumb and point it into the paper or into the screen. Okay, so this would be the direction of the magnetic field. Okay, and then as for the dot sign, the current is going up, so our thumb point upward. Okay, so this is the combination of a current carrying conductor in a permanent magnet. Okay, why do we have two outward current and inward current? It is because we have a coil. Okay, and current going into the screen and then going out of the screen. Okay, so number 3, draw magnetic field lines to show the catapult field. Okay, previously, let's refer to here. Okay, so let's look at this diagram and let's draw another diagram here. Okay, so this is north, this is south, and we have current going out on the left and current coming in on the right. Okay, so let's say on the left and on the right like this. Okay, so on the left, current going out, so direction of current is like the direction of magnetic flux is like this, and on the right, coming in into the paper, so the direction of the magnetic field is like this. Okay, so let's draw again the direction of the magnetic field for the permanent magnet. Okay, so now let's focus at 4 parts. Okay, the first part is on the upper part of the left. Okay, so let's look at the direction of the magnetic field. On the left top, the number of magnetic field will reduce because we have two opposite direction of magnetic field. Okay, and as for the right top, the direction is the same. Okay, so the number of magnetic field will be add on. And as for the lower right part, okay, the direction of magnetic field on the lower right part is less. So this is less. This part is also less. Okay, this part, the number of magnetic field is more. And this part, the number of magnetic field is also more. Okay, so to know whether the number of magnetic flux or magnetic field lines are less or more, we look at the direction. Okay, if the blue color line and the green color line, the direction are the same, then we add. And if the green color line and the blue color line are opposite, so we cancel off lah. Maksudnya bilangan magnetic flux dia akan berkurang. Okay, so if we draw again, the combination of the magnetic field, okay, belah kiri atas less, belah kanan atas more. So we have magnetic field line ni macam ni. Okay, yang ini less, satu line je. Lepas tu yang belah bawah kiri kanan pun satu line je. Tapi yang belah atas ni dapat lebih. Yang belah atas kanan dapat lebih, belah bawah kiri pun dapat lebih. Okay, so kalau kita lihat kepada dia punya catapult field, macam ni. So we have, ini sebab dia terbalik tadi dengan gambar raja tadi. Okay, tadi kat sini dot, yang belah kiri dot, belah kanan pangkah. Tapi yang ini belah kanan dot, belah kiri, dia terbalik. Okay, so that is why dia punya magnetic field line dia terbalik. Okay, so let's look here. Let's say dia follow okay, dia follow not this one, tapi dia follow macam the next slide. So here is pangkah and here is dot. So we get yang ini. Okay, going in. So direction of magnetic field is like this. Yang ini yang macam ni. Okay, yang ni akan opposite. Okay. And then the permanent magnet will be like this. Okay. Direction from north to south. And then bila kita combinekan north, south, pangkah, dot, okay, yang belah atas kiri, the magnetic field line will be more because the blue line and the green line is the same direction, and also the bottom right, the magnetic field line will also become more. Okay, because the direction of the blue and the green line are the same. Okay, so dia akan jadi macam ni. Yang atas ni, dia akan jadi banyak. Okay, and now we focus at the top right and the bottom left. So the direction of the blue line and the green line are opposite. Jadi dia hanya tinggal maybe one line. And then this one also tinggal lagi one line. Okay, so we have a catapult field. And the magnetic field or the magnetic flux are unbalanced. So yang belah sini, magnetic flux dia lebih. So the magnetic force is higher. Okay, force is higher, magnetic force. And here magnetic force is higher also. And then magnetic force is lower kat sini. Yang dekat sebelah sini pun the magnetic force is lower. Okay, so because of the unbalanced forces due to the magnetic field lines yang berbeza, we will get magnetic we will get resultant force. So yang ini, the resultant force is downward. Okay. And then yang sebelah kanan, the resultant force is upward. Okay, same as the next slide. Okay, so the resultant force is downward on the left, and on the right, the resultant force is upward. So since this is a coil, ni coil sebab tu ada dua. Okay, sebab dia coil, so let's say this is the coil, and then this part going down and this part going out, so dia jadi macam ni. Dia akan ada turning force. Okay, so let's look at the next slide. What will happen to the coil in diagram 8 to 7? Okay, diagram 8 to 7, the coil will turn. Okay, so the coil will turn clockwise. Okay, so state the factors which affect the speed of rotation of the motor. Okay, number one, increase the size of current. Okay, we know that when current increase in a circuit, the magnetic field lines will also increase. So when the magnetic field line increase, so we will get bigger forces. Okay, so the rotation of the coil will become faster. Okay, number two, increase the strength of magnetic field. So bila ada magnetic field yang lebih, we get magnetic field lines yang lebih. So bila magnetic field lines lebih, so you get force yang lebih besar. So you will go faster also. Okay, number three, increase number of turn. It will also increase the speed of the coil. Okay, number four, increase the area of the coil. Okay, it will become faster. Okay, area of the coil, meaning that the coil is more, so it will become faster. Okay, so now let's look at the next slide. Okay, this is a motor. Okay, by using a current carrying coil in a magnetic field, we will get motor. Okay, sebab kita ada turning force. Macam kipas kan, kipas is a motor. So kipas tu dia ada turning force, sebab tu dia boleh berpusing. Okay, so this is a DC motor, and as for DC motor, there are a few parts of a DC motor that you need to remember. Okay, one is the coil. Okay, this one is the coil. Okay, and then we have the permanent magnet. Okay, this is the permanent magnet. The north and south polarity of magnet is the permanent magnet. Okay, and then we call this as carbon brush. Okay, this is the carbon brush. Carbon brush is a contact point for the coil to the circuit. Okay, and then we have what we call as a commutator. So as you can see here, the commutator dia bukan satu yang bulat penuh, dia terpisah. Okay, so we have a semicircular conductor dan dia pecah. Dia macam gelang yang pecah. Okay, dia bukan satu gelang yang lengkap. Okay. So, carbon brush ni akan bersentuhan dengan commutator. Okay, dan commutator tu akan berpusing when with the coil. Bila coil tu dapat turning force daripada current carrying conductor dengan magnetic field, dia akan turn lah. And then the commutator is attached to the coil. Okay, so what is the function of the electric motor? To change electrical energy to mechanical energy. Okay, we get current flowing through the conductor. Okay, when current flow through the conductor, we get turning force. So changed electrical energy to mechanical energy. Okay. So A, label the parts shown in diagram 8.2.8. So this is the diagram below here. Yang bawah sekali dekat sebelah muka saya tu. So we need to label. And labeling tadi dia sama macam slide yang sebelum ini. Okay. So the coil, permanent magnet, carbon brush and commutator. Okay. And number three, name two magnetic fields which interact when current flow from A, B, and C. Okay, the two magnetic fields that interact is the magnetic field from the current carrying conductor, and the other one is the permanent magnet. Okay, and number 4, show on diagram 8.2 and state the direction of force experienced by the side AB. So this side AB, okay, current going into the screen. So to determine the direction of the force, we use Fleming left hand rule. Okay, my left hand. So make sure the fingers are all perpendicular. Nampak? Okay, fingers tu mesti perpendicular. Okay, this is the magnetic field. Follow the magnetic field. So always point to north. And this one is the current. Follow the direction of current. And our thumb will show the force. Okay, so let's focus on AB. So AB, the direction of current is like that, is into the screen. And then this is north and this is south. Okay, magnetic field is always from north to south. Tadi saya sebut towards north. So terbalik. So this one point to south. Okay, following the diagram. And our thumb will show downward. So AB will be pushed downward. Okay, and CD, the current is pointing towards me. And then our index finger is toward S and our force is upward. So DC will go upward. Okay, so AB will move downward and CD will move upward. Okay. Number 4, state the rule to determine the direction of the force. Okay, the rule is Fleming left hand rule. And number 6, what is the effect of the two forces produced side AB and CD to the motion of the coil? Okay, we get two forces that is opposite direction, so produce turning effect. Okay, the coil will turn. And what is the direction of the rotation of the coil? So ni C ke atas, D ke bawah. It's like this. Okay, so it is clockwise. Okay. Okay, so